Equations is two or more equations that use the same variables that are used together to model a problem. So, our form of our equations that we've been working with in slope-intercept form. What does an equation, tell your shoulder partner and write it down, look like in slope-intercept? And you can talk to the people behind you. So, slope-intercept form is looking, Logan, like what? Y equals mx plus b. If you take a look at that next page down in your notes, it says, real world problems as we are taking a look at this. Bill and his brother collect comic books. Bill currently has 15 books and he adds 2 books to his collection each month. His brother currently has 7 books and he's adding 4 to his collection each month. Use the equations to find out when will they have the same number of comic books. So it says, as you look at this problem, it says this brace that's out in front, okay, so whenever we're looking at that, is sometimes representing a system. It just means that these 2 equations, we're considering them together. So anytime you have something like this, this just means that these 2 we're looking at together. Does this make sense for Bill's? He started with 15, and he's adding 2 each month, right? If we look at what his brother had, he had 7 and is adding 4 each month. So the first thing we are asked to do is we are asked to fill in this table. So if there are 0 and we replace x with 0, this is, let's write up above this, this is going to be Bill's number of books, right? Comic books. So please write Bill's comic books. This would be his brother's comic books, right? What would the X stand for? What is the X if the Y is their number of comic books? X is going to be our months, right? Because we're talking about each month. So at 0, what did we know Bill had? 15. At 0, his brother had 7. After a month, Bill now has 17. So please fill in the table. His brother now has 11. So please fill in that up by 2 each time. So we should have 19, 21, 23, and 25. Over here, it should be going up by 4. So after 11, I should have 15, 19, 23, 27. All right. So, first question, when will when will they have the same number of comic books? 4 months. So, 4 months. All right, let's go to lunch. When will they be the same? You should have had 4 months. The next question asks how many books will they have, which it should be 23 books. So if we are looking at this, I would like you to write right below here, this is the ordered pair, because we're always going to have an X and a Y. So write X comma Y, and our XY would have been 4 comma 23, right? 4 months, that's our X. These were our Ys, which are going to give us 23. Okay. On the top of your next page, so read, Jack, will you please?
Problem 2, solving systems graph.
Quiet, please.
Suppose the makers of a shopping center want to upgrade their security system.
Keep going.
Suppliers bid for the job. Superlocks will charge $3,975 to install the equipment and then $6 per day to monitor the system and respond to alerts. Failsafe will charge $995 to install the equipment and then $17.95 per day to monitor the system and respond to alerts.
So it tells us both companies are reliable and capable, so the choice comes down to cost. It says what kind of equation will show how the costs of the 2 companies are a function of the number of days. What kind of equation are we talking about? It should be a linear equation. What form are we putting it in? Slope intercept for this one. Okay, slope intercept form. The next question says, what pattern do you expect to see in the graph of the equation? As the months increases, what's happening? If we are gonna graph this, as our months increase, what's gonna happen? The price is gonna increase, right? So we're gonna have two, if it's linear, we're gonna have two straight lines, right? Two straight lines. And when we look at those straight lines, what pattern should we see? They should be both be going up to the right, right? So if we're thinking of those lines, they're going to go up to the right. You're writing this down. It says, how do you use the graph to answer the question for which company is the best price? So that's what we're going to take a look at. For Superlock, what would our equation be? Y equals what? What is our rate of change? This is good practice for the test tomorrow, Chase.
6, right?
So 6 is our rate of change, so 6x. Plus, what was our starting cost? $3,975. Right behind fail-safe, if I am writing that equation, what is our rate of change for each day? $17.95. We're going to have x for our with our rate of change, plus our starting cost was $995. So what we're going to be taking a look at is this is what those two graphs look like. Okay? So fail-safe, if we look at it, started at like $995. The other one we were looking at started at $3,900, so we were close to $4,000. So it says, for what number of days will the cost be the same? Can we find exactly where this point is? In the number of days, it looks like how many days? About 250 days. So we are going to approximate that, but we would say when cost of the number of days, about 250. Can we figure out what this cost would be? If it's about, so maybe like about $5,500. Want to make sure we have a label with dollars here, and this being days. It says, when will Superlock be the best choice? So when is Superlock the best choice? After what? After 250 days. So if you need the security company for more than 250 days, you would probably want to go with Superlocks if they are both the same company, and you're going to be gone for 500 or 600 and you want to have it for a longer period of time. Failsafe would be a better choice from 0 to 250 days, right? Okay. So from 0 to 249. 250, it doesn't matter, right? If you were just going to have them working for 250 days, it wouldn't matter which company because they came out the same, right? So it says write an equation for the PIDs. We just did that, right? So please write those same equations that you have up above down here. So y equals, we should be looking at the 1795 for failsafe plus 995. Superlock should be y equals the 6x plus 3,975. And it says where the point, where the two lines cross, is going to be our solution to our system. And what I want you to write down is that our solutions are always going to be an x, comma, y. It'll always have two variables that we are looking at. So you want to fill in that other part? We did all that. Actually, we are asked to graph them. So first thing I want you to do behind each one is tell me the beginning point. The beginning of the first one, Gunnar, is 4. Ella, the second beginning is? Careful, beginning, the
2.
Right, because we're talking about the mx plus b, so our second beginning is 2. Lucy, if I'm looking at the slope of the first one, the m, the movement, the slope of this first equation. No, slope is not an x, so what number are we talking about is our movement? That's times the x in this equation. What number is in front of x? Okay, but that number, what number if there's no number there? Negative what?
1.
Negative 1. And we're going to write it as a fraction as negative 1 over 1. Cassidy, if I'm looking for the m in that second equation, it is positive 1 over 1. So this first equation, because the slope is positive, has to be going up to the right. This the first equation, or the second equation goes up to the right. The slope was positive 1, positive slope. Here we had a negative slope, right? So we are going to start as you are graphing these. So please start at your beginning point of 0, 4. And if you need a straight edge, there's straight edges up here. Our slope was down 1 and over 1. So please make these as accurate as possible. You want to fill your whole graph with the line so that when you are graphing that, so there are straight edges up in front, so please make sure you grab one. Then we are going to our second equation, which says that my beginning point is at 2, and it has a slope of up 1 and over 1. And again, when you draw your lines on your paper, what I will want to see is that you are extending your line across your whole graph. So if we are looking at this first one, it says graph the system and find the point of intersection. Our point of intersection is this point right here. That point of intersection is always an x comma y. So my x coordinate is going to cross over here, should be 1. And my y coordinate is up how high? Up to 3 as we look at that. So our ordered pair is 1, 3. Then what you want to do is we want to do the check. So please write the word check after you have this 1, 3. And to check, you are going to go to both equations. So the first equation, please write that y equals negative x plus 4. The second equation, y equals x plus 2. So on half of these, Stephen, don't do that. We are going to always be doing our check when you do your homework. To do the check, our y coordinate was what, Kyle? For the answer up here, what was our y? 3. So we're going to put 3, and the question is, does it equal? We are going to put in Jack Mitchell, our x was what? Look up here. 1. So we have a negative, and then we're going to put 1 plus 4. Okay? So x was the 1, and is negative 1 plus 4 equal to 3?
Yeah.
So 3 equals 3, so it works in the first equation. So next, Robert, I'm going to go to the second equation. So I went to this y equals x plus 2. My y coordinate in my answer was what? 3 equals, my x coordinate is 1 plus 2. And 3 does equal 3. So it checks. Stephen.
Where do you get the numbers from?
The 1 and the 3.
Yeah.
Where my 2 lines,
And then how do you get 4 of them?
so I went to this equation to do the check. I said I'm going to write down that equation, and I'm only changing the y and the x from what my answer was.
Okay, and then how do you get the number 1? Well, give me the negative.
So here, because this was negative in front of x,
Oh.
and my x, right, is 1, and my y was 3. So I replaced the 3 where the y is and the 1 where the x is, as I am looking at it. Okay? So making sure you show the check on each one. Please make sure you do that. So let's take a look at the next question. As we look at that next question, Chase, we're going to start with our beginning. Our beginning is, in the first equation, is what?
1.
1, and our slope is going to be what, Timothy?
Negative 2.
Negative 2 over 1. So we know this line is slanted down to the right. If we look at that second equation, Ian, what do I know my beginning is? Careful. Negative 2. And if I'm looking, Haley, what is my slope in that second equation? 1. And we know it is positive, so it's going to be going up to the right, so 1 over 1. So when you are writing those, so now we want to go back and graph it. So that first one, we are starting at positive 1. And our slope was a negative 2. Negative meaning we're going down 2 and over 1. So make sure you fill your whole graph So this is the key, is that some people make segments, and those segments kind of are not usually long enough. So we are now going to take your straight edge, and we want to draw that line. Putting arrows on because it does continue on forever. Then we're going to go to our next equation, and our second equation in this case was starting at a beginning of -2, and the slope was +1. And right away we get that point of intersection. So that's pretty nice if we can get that point of intersection right away. So we're going to have, if we would extend our line. So please write down the ordered pair for where this point of intersection is. Write down that point, that is our solution. It is always an x comma y that you are writing down. And then check with the person next to you beside -1. So we're looking at 1, -1. So now to do the check, Jeremy, what equation do you want to put first? The first one, let's write the first one. So I should write down what? Y equals, right below the word check, first equation, right? Y equals, want to give me the first equation? If we write this down so I know what you're writing on your paper, y equals negative, can you read it? -2 x plus 1, right? That's the equation. You see that? Okay. So now we got to substitute in. So if we start substituting that solution, what did we say the answer was for y? What is our y coordinate answer? What is our y coordinate answer? -1. So we need to write -1 equals, and this is what we're checking. We are then going to write what? -2, but we're not going to put x. What is our x coordinate? It's what? It's 1. So we're going to put -2 times 1 plus 1. And now we are checking. If we take -2 times 1 and we add 1, -1, does that equal -2 plus 1?
Yeah.
Yes, -1 equals -1. Second check. If we are looking at it, Sophia, what is the equation we need to write down for our second check? Y equals x minus 2. Emily, I'm replacing y with what? -1, and the question is, does that equal? Keep going. The x should be 1 minus 2. So is -1 equal to 1 minus -2, -1? And it checks in both cases. Please, if you do not have that written down,